This is lesson 2.3, parallel lines and transversals. What we're going to do is go over parallel lines and transversals, also the angle theorems that you would use in proofs. So first off, I wanted to review vertical angles. Vertical angles are when you have two intersecting lines. They are the lines that are they're angles that are directly across from each other, and they are congruent. Supplementary angles are two angles that form a straight line here, and they always add up to 180. So if we look at this, if we know that this is 150 and we want to know what angles A, D, and C are, we know that the ones directly across are congruent. Those are vertical angles. And then we also know that the ones next to them that form this straight line are going to add up to 180. So angle A must be 30 because 150 plus 30 is 180. And then the angles across from each other are congruent. So this is also 30. So this is how you can come up with the missing angles using the vertical angles theorem and then the supplementary angles theorem. Let's talk about parallel lines. Parallel lines are lines that go in the same direction. They're never going to cross. So these are parallel lines. And also, these train tracks are parallel. If you have a line that cuts across a set of parallel lines, they're called transversals. These are transversals. They cut across two parallel lines. So I remember parallel, just think about the two L's in parallel. They look like parallel lines, if that helps you. So let's look at these angles, and I put pictures here just to kind of help illustrate the relationship. The angles across from each other, remember, are congruent. Mario and Donkey Kong. Luigi and Donkey Kong are congruent. These are called corresponding angles, angles in the same spot. If you notice, this person is to the left of the transversal, and they're both on the top of those parallel lines. They are congruent. These are congruent in the same spot. These are congruent. These are congruent. They're all corresponding angles. So when you have two parallel lines and then a transversal that cuts through, you end up with two sets of four angles that are identical. So corresponding angles are in the same spot and they are congruent. So there's two postulates that can be used in a theorem. If you are looking at a picture and the angles are congruent, then that means that the lines must be parallel. So what we're showing you here is two ways of using this, this fact. If you have two parallel lines and a transversal, then the angles are congruent. The corresponding angles are congruent. That is the corresponding angles postulate. The way this is different is we're saying here, if you have these lines, you don't know if they're parallel or not, but you do know that the angles are congruent, then we know that the lines are parallel. So they're kind of opposite. Are we starting with the fact that we know that the lines are parallel, or are we starting with the fact that the corresponding angles are congruent? So which of these is the corresponding angle to Taylor Swift? She's in the top right. This one right here, Jake Gyllenhaal, is the corresponding angle. So you can use these three rules to find missing angles most times. So this is very similar to your homework question number 2. If we are giving you that this is 60, I'm going to first use the vertical angle rule to say, okay, the one right across is also 60. Then I'm going to use the supplementary angles rule because I know that these add up to 180. So that means that A must be 120. And then again, the vertical angles rule, the ones across from each other are also congruent. Vertical angles, they are congruent. So now that I have these four set up, I know that the ones in the same spot are also congruent. So this is just like this 60. This is 120. So this is 120. This is 120. So this is 120. This is 60. So this is 60. Let's talk about exterior and interior, what those words mean. Exterior means outside. Interior means inside. Like you might have heard the term interior design when you're designing your home inside. So when you are talking about these sort of lines, we have our two parallel lines here. The four angles that form on the inside of those two parallel lines, those are interior angles. The four angles that form on the outside of those parallel lines are exterior angles. So let's take a look at those. Oh, let's also think about alternate and same side. If they're on the same side of the transversal, they're on either the right side or the left side. Or we have alternate sides. LeBron and Kobe are on alternate sides, opposite sides of the transversal. So let's use those definitions to figure this out. Are Jay Leno and Jimmy Fallon interior or exterior? They are interior. Alternate side or same side? They are alternate sides. So alternate sides, interior angles are always congruent. So there's two theorems we can use. If we have two parallel lines, so if we're starting with those parallel lines and they're cut by a transversal, then we know that the alternate interior angles are congruent. That's the alternate interior angles theorem. Where if we have these lines, we don't know if they're parallel, they're cut by a transversal, and we know that the angles, the alternate interior angles are congruent, then we know that they're parallel. So that's the converse of the alternate interior angle theorem. So let's use those in this question. If we are given the angle 3 and 5 are congruent, so if the angles are congruent, which theorem is going to show us that the lines are parallel? So when you are comparing two angles, think, okay, what is their relationship? They are interior angles, and they're on opposite sides. These are interior alternate angles. So the answer is going to be A or B. So let's think. If we are given the angles are congruent, then the lines are parallel. If the lines or the angles are congruent, then the lines are parallel. That's the converse. So the answer for this one is B. So these guys, they are exterior. They are on the outside. Are they on the same side or alternate side? Alternate side. So alternate exterior angles are also congruent. And just like the other one, we have the theorems. If we have two parallel lines, then we know that the angles, the alternate exterior angles, are congruent. Or if we have these lines and we know that the angles are congruent, then the lines are parallel. So they're kind of flip-flop which way. Are these same side, alternate side? Same side. interior. So same side, interior, these are a little different. These two angles aren't congruent, they are supplementary. They add up to 180. Oops. So for this one, we have, again, if you have these parallel lines, then these same side interior angles are supplementary. Or if you have two lines and those angles are supplementary, then you know that the lines are parallel. So let's take a look at this one. If you were given, again, two angles, you want to think, well, how do they relate? What kind of angles are these? Both on the bottom right, they are corresponding angles. So which of the theorems is going to tell us that if these are equal, then they're parallel? The converse of the corresponding angles postulate. So we know that these are congruent because they are corresponding angles. So to figure out what x is, so that these are congruent, all we do is solve this. To solve this equation, we first want to collect the x's on one side of the equation. So I'm going to move this 5x to the other side. So I'm going to subtract that from both sides. I'm putting it underneath the 8x because 8x minus 5x is 3x. 5x minus 5x is 0, so this is our new equation. To move this plus 1, I'm going to subtract 1 from both sides because that's the opposite of adding 1. So now I have 10 minus 1 is 9. I still have my 3x, and that 1 minus 1 is gone now. To undo the multiplying by 3, I'm going to divide by 3. Because 3 divided by 3 is 1, so I just have 1x equals 3. So if x equals 3, and you substitute that in for both of these, you'll see that they are congruent. Therefore, these lines are parallel. So now that we have, we've gone over all the different types of angles, we can list some corresponding angles. There's lots of them. Let's say these two. These are corresponding in the same spot. Alternate interior, inside, alternate sides. So that's B and E. Alternate exterior. How about A and G? Same side interior. How about B and D? Same side. And then in between those two parallel lines. And then vertical angles. They're just directly across from each other. Here's one example, D and G. So let's go over one more here. If I had this proof and I need to fill out the theorems, let's look and see what we have. It's telling us 1 and 3 are supplementary, so we know that they add up to 180 because that's the definition of supplementary angles. Now it's telling us that angle 2 equals angle 3. So take a look at that. Angle 2 is congruent to angle 3. We know that because they are vertical angles. So this is the vertical angles theorem. So what they did is they took that angle 2 and they substituted it in. If 1 plus 3 equals 180 and 2 is the same as 3, then I can just substitute 2 in for 3. So the substitution property allowed me to do that. So when I am saying that these two add up to 180, that means that they are supplementary. So if 1 and 2 are supplementary, what does that mean? Which of those theorems is telling us that if 1 and 2 are supplementary, then these lines must be parallel? So you need to think, these two angles are on the same side interior. Same side interior. This one tells us that if the two angles are congruent, then the lines are parallel.